Today's lesson is 6.2, Find Arc Measures. Let's go ahead and start with some definitions. An arc is a part of a circle. So over here in the sketch, I have a circle. And let's go ahead and add its center. And I'm going to go ahead and create an angle. This part right here from the endpoint to the other endpoint of my angle inside my circle would be considered an arc. A central angle is an angle with its vertex at the center of the circle. So when we go ahead and created that angle in our last sketch, we created what is called a central angle. It separates this circle into two arcs. And you can see them. There's one right here, and then there's a second one right here. Okay, we separate into two arcs. So it might be nice to go ahead. Sometimes you see letters, and you'll see that today. Oh, we could call the center of the circle O. And then maybe there's a little point on my circle over here called C. So I have my arc. I have an arc here from A to B, and then I have a different arc over here, a larger one from A to C to B. All right, I have what are called a minor arc and a major arc. A minor arc and a major arc. A minor arc is an arc whose measure is less than 180 degrees. It is named by its endpoints. So a minor arc would be something similar to what we just drew up above. So let's go ahead and we have A, we have our center at O, and then we have B. This right here from A to B would be considered my minor arc. My major arc is an arc with a measure more than 180 degrees. It is named by its endpoints and one other point on the arc. So let's go ahead and on both of these, let's go ahead and put point C. So we've got A, we've got our center at O, we've got B, and then we've got C. My major arc, let's make it a different color, is going to be this one right here, from A to C to B. And if I were to name it, if I were to name this arc, I would call it A, C, B, and I would go like this. And if I were to name my minor arc, I would simply call it A, B, and I would put my arc above it. All right, we've got one last term to talk about, and that is a semicircle. A semicircle is an arc whose measure equals exactly 180 degrees. It is named by its endpoint and one other point on the semicircle. To find a semicircle, you need to find the diameter, and this would be my points, and then C would move right here, and my semicircle, let's go ahead and change it to this color, would be right here. Or of course, the bottom could be my semicircle, but I chose the top because of point C. And if I were to name this, I would again call it A, C, B, just like I did for the major arc. But because it is a diameter, I'm going to go ahead and this one would be called a semicircle. Okay. All right, when we are measuring arcs, the measure of a minor arc is the measure of its central angle. The measure of a minor arc is the measure of its central angle. This expression right here is read as the measure of arc AB. The measure of the entire circle, is 360 degrees. The measure of a major arc is the difference between 360 degrees and the measure of the related minor arc. The measure of a semicircle is always 180 degrees. So let's go ahead and take a look at our picture over here. I know that this angle ACB is 50 degrees. Because this is a central angle, that means that this arc from A to B measures 50 degrees. This is my minor arc. Because ADB is my major arc and is the rest of my circle, to find its measure, to find this measure, I do 360 minus 50, and this is where the 310 comes from for ADB. All right, we have one more postulate that we need to look at before we look at our two examples today, and this is my arc addition postulate. This is just a rule about how I can add arcs in a circle. The measure of an arc is formed by two adjacent arcs is the sum of the measure of the two arcs. So here I'm looking at arc ABC. That means I'm starting at A, I'm going to B, and I'm ending at C, my endpoint. The measure of this arc can be thought of as the measures of arc AB from A to B plus the measure of arc BC. Okay, right here. So basically what I can do is I can think of the measure of this whole arc as this part plus that part. Okay, just like we thought of um, in our segments in the beginning of geometry. All right, let's go ahead and take a look at our first example today. FD is the tangent of circle O. Now, that's going to tell me some stuff from our last lesson. I know the stuff about tangents, so I might want to look back at my notes from Monday or Tuesday. And because they're calling this circle circle O, I know that O is the center. So any angle that is made from angle O would become a central angle and would help me out, okay? And also any segment connecting O to the outside of the circle is going to be a radius and or could be a diameter if it is straight. All right, based on the angle measures given, find the measure of each of the following. So they want a whole bunch of arcs. They want a whole bunch of arcs. And then down at the bottom, we're asked about some angles. So let's go ahead and start, and let's keep in mind that this whole circle O measures a total of 360 degrees. Always a circle 360 degrees. Okay, so let's start adding stuff up. I can see that I have a 45 degrees, and I can see that I have a 90 degrees, and I can see that I have an 85 degrees. So let's start adding that stuff up. So we've got 45 plus 90, that's 135, plus the 85, that's going to give me 220. All right, and now I've kind of hit a snag. I don't know where to go from there. But let's go back and let's let's talk about this being a tangent. Since this line is a tangent, that means it has to be perpendicular to the radius. OD is my radius because remember it's called circle O, so this is the center. So that means this has to be a 90 degrees. Okay, let's add that in there. Let's add that in there. There we go. Okay, let's keep thinking. Well, I can see that I have a triangle right here, and I know a triangle is 180 degrees. If I already know two of the angles of my triangle, I can find this third and final angle. So let's go ahead and let's add together the 90 plus the 38. That would be 128. And let's take that away from 180 because we know that it is a triangle. And that would give me 52. So we were focusing right here on this triangle. Let me see if I can trace it nice for you. There we go. And we've just learned that this degree of this angle is 52 degrees. Okay, let's go ahead and add that to our 220. So we can go ahead and say that that plus the 52, that gives me 272. I have one final angle to find in my triangle. All I need is this angle right here. Remember we said at the beginning that the whole circle is 360 degrees. So all I have to do is take 360 and this right here, which is all of this part of the circle, and subtract them. So all I have to do is 360 minus 272.88. I have found all the angles inside of my circle, which means I also know all of their arcs. Since this angle is 45, this arc is 45. Since this angle is 90 degrees, this arc is 90 degrees, and so on and so on and so on. So let's go ahead and let's take a look. A wants me to find the arc AB. So we just actually showed, I just actually showed you that one. There we go. Now, then B wants AD. Now be careful because you could go this way or you could go that way. And how do you know which way to go? When they only use two letters to name an arc, they are naming a minor arc. Whenever I name a major arc, I need three. So you have to look at the two angles from A to D and you have to say which one of them is smaller. This one. This one is smaller, so this is the one they want. I'm going to take 88 and I'm going to add to it the 52, and my answer is 140 degrees. All right, same thing. AC, they want the shortest distance from A to C. That would be this right here. 45 plus 90, 135. I already did that combo. There we go. BC, we already talked about that. That's 90 degrees because of the central angle. ADC, so notice now we're opening up and we're using three letters to name the arc. They want the major arc following the letters in order from A to D ending at C. So I've got 88 plus 52 plus 85, 225. Ooh, that squeezed in there. And then ACD, so now we're going to go A to C to D. I've got 45 plus 90 plus 85, and that would be 220. E to D, that's the 52, because remember they match the central angle. And A to E would be 88. All right, now I've done all my arcs. Now I'm going to go ahead and I'm going to do my angles. Remember when I name my angle, I'm just following the letters in order from D to O to F. D to O to F. Oh, right out here. There's F. D to O to F. 52. And E to O to A. 85. All this was adding and subtracting and remembering facts about a circle, 360, and facts about a triangle, adding to 180 degrees. That's all that we were doing here. Let's go ahead and take a look at our next example. Find the measure of each of the following. So notice in my circle that I have the arcs this time. This time in my circle, I have the measure of all of these arcs. Okay, all four of them. And they're asking over here the measures of the angles. Take a look at A. It's AOB. So if I can figure out what this arc is, I can figure out what this angle is because O is the center of my circle. Well, I remember that a circle adds up to 360 degrees. 360 degrees. So I think I can make an equation of 2x plus 120 plus x plus 4x plus 2x plus 60, and that should give me my 360 degrees. So I can take this arc, add this arc, add that arc, and add this arc, and I've gone all the way around my circle, 360 degrees. All right, let's go ahead and combine together our like terms. So let's take together and add 2x plus 1x plus 4x plus 2x. So 2 plus 4 plus 2 plus 1. Oh, I missed the 1. 2 plus 1 plus 4 plus 2 would give me 9x. And then I can go ahead and I can add together 120 plus 60. 120 plus 60 would give me 180. I'm going to go ahead and subtract the 180. I'm just solving for x. Bring down the 9x equals 180. I'm going to divide both sides by 9. X equals 20. Now all I have to do is go back and plug this in. So this angle is 20. This one would be 4 times 20, which would be 80. This one would be 2 times 20 plus 60. That would be 40 plus 60, 100. And this one would be 2 times 20 plus 120. That would be 40 plus 120. That would be 160. And so now I have all my answers. I've just got to go ahead and take a look at my answer choice, the way they want them. AOB. AOB, that would be 20 degrees. BOC, BOC would be 80 degrees. COD, COD would be 100 degrees. And finally, AOD, AOD would be 160 degrees. All right, the last thing I want to talk to you guys today about is when two triangles or when two circles, sorry, we talk about triangles so much, I'm sorry. When two circles are congruent. And remember, this is my symbol for congruent. So when are they exactly the same? They are if they have the same radius, if they have the same radius. Two arcs are considered to be congruent. And there's my symbol for congruent. If they have the same measure and they are of the same circle or circles that I already know are congruent. So let's go ahead and take a look at this last example. And my question is, are these arcs congruent? Explain why or why not. So remember, for the arcs to be congruent, they have to have the same measure and they have to be of the same circle or congruent circles. So let's take a look at this first one. Are these arcs from WZ and XY the same? Well, I can see right here that they both are 180 degrees. This means that they match. They have the same arc. So I'm going to go ahead and write that down. They have the same arc. 180 degrees, because that's one really good fact. The other thing they have to have, though, is the same radius. So let's take a look at the radiuses. What is the radius of the larger circle? Well, let's focus only to the right side. It would be right here from this circle to Z. This would be the radius of the larger circle. What about the radius of the smaller circle? This circle. Well, it would be from this center point to the letter Y. The only thing that worries me is this little part right here. This little part right here is not in the small circle. It's only in the large circle. So I'm going to say, but different radius. I'm going to say that they are not equal. I'm going to say that they are not congruent. Their radiuses just are not the same. They just are not the same. Okay, let me show you maybe with some color here. So there's this one, and there's the second one. Now you can see it, right? Now you can see that there's this little part right here that's not in both of them. All right, let's take a look at our last one. I can very easily see that I have the same arc, 135 and 135. So let's go ahead and write that. Same arc, 135 degrees. Now let's go ahead and take a look at the radius. The radius of circle G, which is this circle on the left, would be GE or GF. Those would be my two radii. My radius of circle F on the right would be FH or GF. So once again, they both have this for a radius. So let's go ahead and look at this. They both have this for a radius. So I'm going to say and same radius, which would be GF, which is my teal one. So I'm going to go ahead and say these two circles are congruent.